Yeah. Okay. So good morning. So we'll continue the class. Now, last class I think we are done with what was called as the analog to digital converter and digital to analog converter. Okay. So in the digital to analog converter, if you remember, we have done two different types. Okay, two different types of digital to analog converter. One was the binary weighted input to D bar A converter. Okay. The other one was R to R ladder D bar A converter. Okay. Right. Then we'll proceed today. Okay, with what is called as digital signal processing. Okay. Now we'll try to understand about what is called as introduction to introduction to digital signal processing. Okay, right. Now, in this case of digital signal processing, okay, basically the signal what we are going to process is what was called as the digital signal. Okay. So, by the way, can we understand what is the meaning of digital signal from your side? What is the meaning of digital signal? What is the digital signal? Is it continuous signal? Is digital signal a continuous signal? Okay, so digital signals are called as the discrete signal. Okay, digital signals are called as the discrete signals. Okay, right. Now they are going to, okay, so discrete signal, not continuous. Okay, so this is very important, not continuous. Okay, and only present at discrete times. Okay, right. Now, why you need to process this digital signals is important. Okay, why to process? Okay, the question is why to process is important. Okay, why I need to process a digital signal? Okay, basically the DSP. Okay, so this is generally called as very popularly called as DSP. Okay, which is the one which is a part of a particular subject itself in electronics and communication. Okay, now here we'll be very discussing only about what is the basic concept of this digital signal processing. Okay, so basically digital signal processing, that is DSP, is the processing of the signal by digital means. Okay, now any signal that you are going to process through digital means is what is called as DSP, and basically it consists of stream of numbers. Okay, now these digital signals are going to be consists of stream of signal which is going to be present in the form of what? In the form of the binary. Okay, it's going to be in the form of the binary form. Okay, that is, binary form is nothing but it is going to be either in the form of 0 or 1. Okay, now this is what is the basis of thing. Now why we require is digital signal processing is, now as we already discussed, okay, we have what are called as the analog to digital converter. Okay, analog to digital converter is going to be there. Now the output of the digital converter is going to be what is called as your digital data. Okay, that is going to be in terms of 0 and 1. Now you need to do certain processing on that. This processing is what is called as your DSP. Okay, now DSP is nothing but it is a processing of digital data obtained from analog to digital converter. Okay, now this is still it is going to be what? Still it is going to be a digital signal. Okay, so after the processing you are going to get a digital signal. Then if it is required, again you are going to use what are going to be called as the D bar A converter. Okay, you are going to use what are called as the D bar A converter for the purpose of converting digital to analog data. Okay, now this is the process. Now this is what is very important for me, that is digital signal processing. Okay, now this figure indicates the basic elements of digital signal processing. Okay, now what is going to happen is this DSP is very much required. Okay, why DSP is very much required is majority of the signal. Okay, so majority of the signals, majority of the signals are of analog in nature. Okay, this is very important. Majority of the signals are analog in nature. Okay, but it is not possible to process. Okay, so it is not possible to process. Okay, this analog signal. Okay, now because you require, okay, what is called as the digital data. Okay, you require what is called the digital data. Now for the purpose of digital data, you need to process the digital signal. Okay, the processing, hence the requirement of digital signal processing. Okay, when I'm going to process the signals, okay, when I'm going to process the signal by means of a digital data, okay, when I'm going to process the signal by means of digital data, now the what are the processes that I am going to do is, as you already done with, okay, I am going to do what is called as the amplification of the digital data, or I am going to do what is called as the filtering of the digital data is the cases what we are going to carry out, okay, in case of the digital signal processing. Okay, now in DSP basically there are plenty of applications which are going to be there, and plenty of softwares are going to be there which is going to be used to perform this digital processing. Okay, now with the help of the processors, okay, with the help of the software, we are going to process these operations, and for that we have D-Barrier converters are going to be there. Okay, now these D-Barrier converters are going to be used for the purpose of the conversion from digital to analog data. Okay, so in this process we'll try to understand what is called as an important one called as the pulse modulation. Okay, please make a note of this. Under the digital signal processing, we'll try to understand what is called as the pulse modulation. The pulse modulation is nothing but it's a process of changing. Okay, please make a note of this process of changing continuous time signals into sequence of pulses is called pulse modulation. Okay, changing the continuous time signal into sequence of pulses is called pulse modulation. Okay, right. Please tell me, changing continuous time signal means what? What is this type of signal called? What is continuous time? The continuous time signal data is called as analog signal. Okay, into sequence of pulses is called as what?
Digital.
Okay, sequence of pulses is nothing but a digital. That means now the pulse modulation is basically a process of changing continuous time signal into or continuous digital analog signal into what are called the digital signal. Okay, now this is the pulse modulation. Now, how do we do pulse modulation? Types of pulse modulation. Let us go further to understand what is called as types of pulse modulation. Okay, if you go to the types of pulse modulation, okay, two types of pulse modulation present. Okay, first one is called as pulse amplitude modulation. Pulse amplitude modulation. Okay, in this case of pulse amplitude modulation, now if you just observe something like this is going to be my time signal. This is going to be my voltage or any signal for that matter. Okay, so assume this is going to be the signal, right? What is this I am writing? What these two lines indicates? What this indicates? What is this? What is this signal? This one is what? What is this type of signal?
Sample signal.
Okay, this is analog signal. What are these? This is sampling signals. Okay, right. Now, in this case, what is that we are doing? This is called as pulse amplitude modulation. Okay, in pulse amplitude modulation, okay, please observe. In pulse amplitude modulation, the width of the signal, okay, the width of the signal is same. That means this one is same. The width is going to be same. Okay, but what is the height of the signal? Height of the pulse. What is height of pulse indicates? What is height of pulses indicates? What is the height of the pulse indicates? What is this indicates? Height of the pulse. What is it is telling? What is this?
Bit level.
Huh? What is that called as? What is the height of the signal indicates?
Quantization level.
No, first of all, the height of the pulses indicates the amplitude of the signal. Are you understanding? Okay. Now, please observe. Okay, I am just trying to give in a simplest manner. So I have drawn what is called as this. Okay, I have drawn this. Correct. Okay, so this is the analog signal. Now, in this analog signal, I have took the time pulses, that is T1, T2, and T3. When it is going to touch the analog signal, okay, I will be getting like this. Okay, if you observe, so if this is going to be the signal, one value will be here, another value will be here. Okay. Now, if I write this actually, it is going to be like this. Yes or no? I am taking only this. Okay. Can I have a pulse like this? Whether the amplitude is this is the amplitude or this is the amplitude. What should I do? What is that I have done in the last discussion? Somebody has mentioned. What is that I have done? Which process I have adopted to make it normalized? To normalize the amplitude? Somebody has just mentioned now. Somebody has, yeah, okay, to normalize, to normalize the amplitude, we are going to use the process called as quantization. Okay, what is quantization means? Quantization is the process of normalizing the signal. Now here, if I am going to quantize, okay, right? Now either it is going to be like this. Are you understanding? Okay, or it is going to be like this, depending upon the level of quantization. Are you understanding? Okay. Now, in this case, what have you done? You have, if it is the case, okay, if this is going to happen, what is that you have done? You have this portion. What have you done? You have removed. Or what is that you have done? You have done the process called chopping. Chopping means what? What do you mean by chopping?
Cut.
Okay, chopping is nothing but cut. Okay, so on the top portion you have just chopped off. Okay, what is that you have chopped off? When you are going to normalize the signal, you have chopped the one which is not nearer to the quantization level. Okay, now in case of pulse amplitude modulation, the method of conversion of continuous time signal into a sequence of pulses can be achieved by chopping the DC signal. In this case, I have chopped the voltage. I have chopped the voltage which is nearer to what is called as the quantization level. Okay, so in case of pulse amplitude modulation, the height of the pulse is important. Okay, height of the pulse is the value of amplitude, is the value of the amplitude. Okay, is the value of the amplitude. But what about the width of the pulse? Width of the pulse is what?
Same.
Same. Okay, width of the pulse is constant. Okay, therefore, now in pulse amplitude modulation, you have converted the analog signal into digital signal by having the intermittent pulses. The width of the pulses are going to be same. The height of the pulses only matters. Okay, this is one particular thing. Okay, of pulse modulation. Okay, then the other method is going to be what is called as, the first one is pulse amplitude modulation. Third one is pulse width modulation. pulse width modulation. Okay. So in pulse width modulation, okay, so pulse amplitude modulation is PAM. Please note down, pulse amplitude modulation is PAM, pulse width modulation is PWM. Okay, right. Now, in pulse amplitude width modulation, this is going to be the signal, please understand. Okay, so this is your which signal? Continuous time signal. Is it analog or digital?
Analog.
Analog. Okay, right. This is the voltage. Okay, this is going to be your time. Right. Now I am converting this into my equivalent analog digital signal. Okay. What is the digital signal now? Okay, right. Now you tell me now. Okay, right. Now observe very carefully. In pulse width modulation, I have converted this analog signal into a digital signal. Okay. So this is equal to this. Are you understanding? This analog signal, this is equal to this. Now in this case, amplitude are all same. Okay. Can I say as the amplitude is going to be same, the signal level of the signal is going to be uniform? Are you understanding? Hello?
Yes, sir.
Now in this, what I am telling is, in this, what is the amplitude value of the amplitude? Is it same or different?
Same, sir.
Okay. Now the amplitude level is same. Is the amplitude level same? Is it meaning that the time signal, that is the continuous time signal, is having same voltage value?
No, sir.
No. Now in this case, in the left diagram, if you observe, at every time there is one particular voltage. At time t1 there is one voltage. Correct? Understanding? Yes. At
Yes,
time
sir.
t2 there is one more voltage. At time t3 one more voltage you are going to get. Yes or no? Correct? What is the amplitude of this? Amplitude of this is V1. Amplitude of this is V2. Amplitude of this is V3. Okay. But I am saying in the diagram, amplitude I am making it same. Is it I have done correctly? I have made amplitude same. Is it exactly representing this diagram, left diagram? ಅರ್ಥ ಆಗ್ತಿದೆಯಪ್ಪ?
Yes, sir.
Okay, in one more diagram I am writing. Okay, this is correct. ಅರ್ಥ ಆಗ್ತದೆ ಇವಾಗ? Okay, just observe. This is a diagram, one diagram I have done. This is another diagram. Okay, this is correct? The second diagram is correct?
Yes,
What is the
sir.
amplitude? What is the amplitude here?
Constant, sir.
Constant. What is the width?
Constant, sir.
Amplitude is also constant, width also constant. Okay. For this, what should be the analog signal? The analog signal is this. Are you understanding? This is the analog
Yes, sir.
signal. Correct? If this is the analog signal, whatever I wrote is correct. Yes or no? Right? Now, what is the analog signal now here? It is increasing. Okay, it is increasing. Okay. First case, I have made the amplitude same. What is the width? Width is this much. Okay. In the second signal, please observe, in the second signal, I have kept the amplitude same. Okay. But what is the actual value of the amplitude in the analog signal, is it more than the previous?
Yes, sir.
Okay, then what is that I have to do now? What is that I have increased here? From year to year, what has increased? Amplitude has increased?
Yes, sir.
Hey, is the amplitude has increased from this diagram to this diagram, from A to B?
No, sir.
Then what has increased?
Width, sir.
No, sir.
Width has increased. Okay, width has increased. Okay, then go to C. Okay, is the amplitude has increased?
No,
No,
sir.
sir.
No. What has happened? The width has increased. Okay, why the width has increased? Because in the previous diagram, what is going on? The voltage level is increasing. Are you understanding? In pulse width modulation, please understand, in pulse width modulation, the amplitude of the signal is constant. Are you understanding? The amplitude of the signal is constant. But what is varying? What is varying? What is varying? The width of the signal is varying. The width of the signal is varying. Okay. Now you tell me, in pulse amplitude modulation, what was the condition? Now, for the same diagram, if you observe, I'll write here. Okay, same diagram. I'll take the same example. Okay, right. Are you understanding? This is the thing. In pulse width modulation, sorry, pulse amplitude modulation, in pulse amplitude modulation, what was the case?
Width is same.
Huh? Width
Width
is
is same.
width is same, but amplitude is
Height of the pulse is varying.
okay. Now amplitude is like this, correct? This one amplitude. Next is this is the amplitude. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now in this case, what has happened? With reference to increase, the amplitude width is same. The width of the amplitude is same, but the amplitudes are going to be different. Yes. What is this method called as? Pulse amplitude modulation. The same thing I will write for pulse width modulation. Okay. If I write for pulse width modulation, okay, if I write for pulse width modulation, for the same thing, what is going to happen to the amplitude? What is
Constant.
going to happen to amplitude?
Constant, sir.
Constant. Okay. Now, one amplitude. Next amplitude should be at the same thing. But what should I do now? I should
Change the
increase
width.
increase the width of the previous. Correct? Then third one, increase the width much more. Are you understanding? Getting it or what?
Yes,
Yes,
sir.
sir.
Yes, sir.
This is called as pulse width modulation. Okay. So in case of pulse amplitude modulation, the amplitude is varied. Amplitude is varied. Okay. Correct? Amplitude varied. What constant? Width constant. Yes or no? Width is constant. But in pulse amplitude modulation, amplitude is amplitude is
Constant.
constant. Amplitude is constant. But width is
Increases.
huh?
Varied.
Varied.
Varying. Okay. Now, depending upon the type of modulation that you are going. Now that's why I took one example. Okay, and I have shown both the thing. Now these are the two different methods of what are called as the modulation. That is, one is pulse amplitude modulation and another is pulse width modulation. Okay, so these are the two methods of pulse modulation under what is called as your the digital signal processing. Okay, right. So this completes what is called as the signal conditioning chapter. Okay, now signal conditioning chapter. Okay, if you remember, okay, we have what is called as this. Okay, now I'll just show you the signal conditioning chapter which is there. Okay. Yeah, now if you just observe, So this is a signal conditioning chapter. Can you able to see the thing on this screen?
Yes, sir. Yes, sir.
Okay, right. Now you just observe the top one, signal conditioning. This is the thing what we have discussed, signal conditioning. Just go through. Okay, I will just again write what have we done in the whole of the signal conditioning bit extensively. Okay, so this is the portion of signal conditioning. Just check whether we have done all the content. Okay, right. Now I'll just now move on. Okay, now to before I'll close off. Okay, I'll just complete this. Okay, right. The thing what we have discussed was signal conditioning. So please note down this. This gives you a complete detail. Okay, right. So we have started with what is called as the definition and then the necessity. Okay, right. Definition we have discussed, and then the necessity of the signal conditioning. Then we have done what are called as the processes of signal conditioning. Okay, please understand. So we have done processes of signal conditioning. Okay, right. Then after the processing, what have we done? Tell me. Take out your notes and tell me. Next.
Amplifiers.
Amplifiers. Okay, in amplifiers, what are all the things that we have done? Tell me one by one.
Definition.
Okay. For that. Okay. Dhanush, Mithun, Arsha, Srinidhi, Sukrut. Okay. Yeah. Tell me one by one. Yeah. Amplifiers, what have we done?
Definition, sir.
Definition. Then after that, we have discussed the meaning of operational amplifier. Why we call this as operational, that we have discussed. Then we have discussed what are called as the features. Okay. In the features, there were totally 4 features we have discussed. That is, input impedance is very high, output impedance is very low. It is a differential amplifier, and the gain of the amplifier is very, very larger. Okay. Then we have discussed what is called as the pin configuration. This is very important. Okay. We have discussed what was called as the pin configuration. Okay. Then after the pin configuration, we have discussed types. Okay. Types of operational amplifier. Remember. Okay. One was the inverting amplifier. Inverting amplifier. Okay. If you are going to give the signal, the output is going to be what? The output is going to be what? Inverted or non-inverted? The output is inverted. The output is inverted, and the phase is going to be changed. Okay, if it is inverting amplifier, okay, right? If it is inverting amplifier, okay, right? If this is the signal that you are going to give, the output what you are going to obtain is inverted but out of phase. Inverted out of phase. Okay, so this is the output. Okay. Second one is going to be what? Second one is non-inverting. Okay. Second one is non-inverting. The non-inverting, if this is the signal, okay, so this assume this is a signal, the output is going to be what? The output is going to be increased, but it is going to be in phase. Clear? Right. Third one is going to be what?
Summing amplifier.
Summing amplifier. Okay. Right. Summing amplifier. What is the output here? Output is what is the output? Output is the summation of. Correct? Tell me, somebody. What is the output? One by one.
Output is inverted sum of input voltage, sir.
Okay, output is the inverted sum of the input voltages. Okay, so that is the summing amplifier. Okay, then next we have what is called as, next one you tell me.
Integrating amplifiers.
Integrating amplifier. In integrating amplifier, we have replaced the resistor by using what? Capacitor. Okay, integrating amplifier. Okay, right. In this case, the output is going to be what? The output is going to be what?
Proportional to input voltage.
What proportional? Proportional or integral?
Integral of input voltage, sir.
Yeah. The output is going to be integral of. Okay, the VO is proportional to integral of V in. Okay, so that is very, very important. Okay, then fifth one was what?
Differential amplifier.
Differential amplifier. Okay, fifth one was differential amplifier. Okay, right. In differential amplifier, The output is going to be the what? Proportional to difference between the
two input voltages, sir.
difference between the two input voltages. Okay. Then sixth one was
A logarithmic amplifier.
logarithmic amplifier. Okay. Right. Now to get the logarithmic amplifier, what have you done? You replaced what?
Diode, sir.
Huh?
Using of diode.
Yeah. You have used what are called as a diode. Okay. So if you have used diode, okay, so you are going to get the logarithmic amplifier. Okay. Now this is going to be used to convert non-linear signal into linear signal. Okay. So this is about the signal conditioning. Very, very important. Okay. After that, you have discussed what is called as next one.
Protection.
Just it's a revision. Okay. So I don't want to go to next chapter. That's why I'll just finish it off with the revision and then let us start a new chapter in the tomorrow's class. Okay, protection. What are protection devices we have done? One is using a series of resistors. Okay. Other one is what? Other one is use which diode?
Zener diode.
Zener diode. Okay. Use Zener diode. Okay. Use Zener diode by which you can able to avoid. Okay. Right. After protection, next is
Filters.
filters. Okay, very important. Okay, so I gave the test question also on filters. Okay, right. So filters is to remove unwanted signals. To remove unwanted signals. Correct. The filters are going to be used to remove unwanted signals. Okay, what type of filters are going to be there? So one is low pass filter. Okay, so what is low pass filter? Can somebody quickly say? It is from 0 to FC, correct or what? 0 to FC. FC is nothing but cutoff frequency. Okay. Then high pass filter. What is high pass filter?
FC to infinity, sir.
Greater than FC up to infinity. Correct? Up to infinity. Okay. Then next third one.
Band pass filter, sir.
Band pass. Okay. Right. What this band pass does?
It allows all the frequency within certain bands, sir.
Yeah, it allows the frequency within certain band. Okay, that means FC1 to FC2 is allowed. Okay, correct? Yes or no? Right. Less than FC1 not allowed, greater than FC2 also not allowed. Okay, then next is band
Stop
Pass
band
filter.
stop filter. Okay, right. Then this one
Reverse stop.
reverse of this. Okay,
Less than FC1 and greater
then
than FC2 are
FC1
allowed.
is allowed.
Reverse stop.
Okay, greater than FC2 is allowed. Yes or no? Clear? Right. So this is about the filters. Then after the filters, next is
Wheatstone bridge.
Wheatstone bridge. Okay. We have discussed what was called as Wheatstone bridge. Okay. Wheatstone bridge. Then derivation we have discussed. Okay. Just remember. Okay. These are the points what we have done. Okay. Derivation we have discussed. Then later on, after Wheatstone bridge,
Data acquisition.
data DAQ. Okay, data acquisition. Okay, so data acquisition we have discussed about how the data is going to be acquired. Okay, then we have discussed what are called as multiplexers. Okay, so we have discussed 8:1 mux. Okay, 8 signals are going to be there. So if you remember, so this is going to be the thing. So we have totally 8 signals are going to be there and there is one output. Are you understanding? So this is what is the reverse of multiplexer is what?
Demultiplex.
Demultiplexer. Okay, demultiplexer.
Demultiplexer.
Okay, it means 1:8 mux. Okay, that means you will be having one signal. Okay, you will be having one signal and you will be having totally 8 different output signals. Okay, so I have given the table for you to understand. Okay, then after multiplexer, demultiplexer, then we have discussed next one, analog and digital signals. Okay.
Analog and digital signals.
Analog and digital signals. Okay, then important is difference. Okay, we have discussed. Okay, then later on, analog to digital converter. Clear? Okay, right? Are understanding? Here we have discussed about sampling. Okay, then about quantization. Okay, quantization and important the various figures we have discussed. Okay, then next is D bar A converter. Okay, how many types? 2 types. Clear? Okay, are you understanding? Okay, then here which are the 2 types? Can I have quickly?
Binary weighted input.
Binary weighted input resistor. Then next one was
R to R ladder.
R to R ladder. Okay, right. So this is what we have discussed. Okay, then we have discussed what is called as digital signal processing. Okay, that is processing digital signals. Okay, under that we have discussed pulse modulation. Okay, right. So how many pulse modulations are present? Pulse amplitude modulation. Okay, in this case, amplitude is varied. Correct? Amplitude varied. Pulse, sorry, the width constant. Okay, but in pulse width modulation, amplitude is constant, but width is varied. Okay, right? Is it clear now? So these are the different types of the signal conditioning devices what we are done. Okay, right. So this chapter is completely about the signal conditioning. Okay, and completely done with the concept of signal conditioning. Okay, and when you come for the next class tomorrow morning, okay, we'll start with a new chapter. Okay, so I just want all of you to be in the class exactly at by 8:30. Okay, so max 8:35. We'll just start with the new chapter. The new chapter name is basic system model. Okay, so this is completely different from what you have learned. Okay, so this about the concept of mechanical building blocks, electrical building blocks. Okay, and then thermal building blocks. Okay, so there is some good amount of derivations are going to be there in this chapter that we'll discuss. Okay, right. So this is the content. What is that I am going to do tomorrow? Okay, now I think so I think it's sufficient for today. Okay, so we'll just come back and discuss in the next class. Okay, so all of you are there. 1, 2, 3, 4, 5 members. Okay, who is absent? Who is absent? Mohan Ambal and one more. Sandesh. Yeah. Okay, right. Okay, I'll make a note of it. So how was the test? It's okay. Could you do well?
Yes,
Yeah.
sir.
Okay. Fine. Good. Okay. Right.
Yes, sir.
So yeah. So we'll just stop at this stage and we'll meet in the next class. Okay. Thank you.